Okay, so here's where we left off yesterday, and there's nothing new here. So one of the things that we're going to run into, these are some of the patterns that we saw before when we were factoring. Again, a lot of what we did yesterday was the same things that we've done before. So one of the things that we did before was the difference of two squares. This is not any difference to that. This is the same exact thing. If you notice, there are two things that are squares. X squared is a square, and 49 is also a square. Okay, so anybody remember what we're supposed to do with these? The difference of two squares? Yes, sir.
Could you do you add the 49 to the other side, or can you factor?
That is a way. So that there's nothing wrong with that way. It's actually, I'll do both ways that we can do that. There's an actually much faster way. It does end up just factoring to x plus 7 and x minus 7. It'll always be a plus and a minus, and it'll always be like, notice that the x was split up into x, and the 49 was split into 7 and 7. Now let me show you what Raul was talking about there. He's got x squared is he's going to add 49 to both sides, and he gets to here, and then he's going to take the square root of both sides. And when he does so, he gets x is equal to plus or minus 7. And you're going to see that our answer is actually going to be the same thing over here. We've got x plus 7 equals 0 and x minus 7 equals 0. We still have to solve it. So x is equal to negative 7 and x is equal to positive 7. If you notice, these two are exactly the same answers as this one. Both two different ways, same exact answer. All right, moving on to B. Again, another difference of two squares. Except for this looks a little bit different. 100 is definitely a square. It's 10 times 10, right? It's 10 squared. Is 64 a square?
Yeah.
What is it? 8, look what number? 8 squared. And then we get x squared. So it's still going to be one thing, plus and one thing minus. In this case, we've got 10 and 10 to make up 100. And in this case, we needed an 8x, 8x. 8x times 8x would be 64x squared. So we break it down into 8x plus 10, 8x minus 10. Then we're going to go from there. 8x plus 10 equals 0. 8x minus 10 equals 0. We are going to subtract 10 over here, and we get 8x is equal to negative 10. Divide by 8. Divide by 8. And we get x is equal to negative 5/4. And over here, we're going to get 8x equals positive 10. Divide by 8. We get x is equal to positive 5/4. So we get plus or minus 5/4. Two answers. You could write it as one answer, plus or minus 5/4, because it's the same number, just one is positive and one is negative.
Or were we still allowed to just do it the other way? That way?
Yeah, so if you're saying, what you definitely could do is you can still do the square root. If you want to do it like this, you could do 64x squared is equal to 100 by adding to both sides. You could divide by 64, and we get x squared is equal to 100 over 64. Take the square root of both sides, and we get x is equal to plus or minus 100 over 64. We're going to break it up, and we get 100 over 64 again, which becomes, did I do something wrong here?
You factored to 10.
Oh, yeah, it's because I was sitting there going, this is going to come out to the wrong answer, but I still have to reduce it, that's why. This is going to be 10 over 8, which will then, again, reduce to 5/4. So either way will get you there.
Where did the 8x plus 10 come from, and the 8x minus 10?
Where did it come from?
Yeah.
The difference of two squares. The two things that multiply to give me 64x squared are 8x and 8x.
Okay.
And the two things to multiply to give me 100 are 10 and 10. Okay, even though it doesn't look like it, this is the difference of two squares. Why?
Because 1 is a square, 2 is 5 is a square.
Yeah, but it's supposed to be the difference of two squares. That does not look like the difference of two squares to me. However,
If you flip them,
well, when you flip them, what does that mean?
like if you put the 1 in front of them.
How about this? What if I divided everything by negative 1? Just to see what happens. This would become 225x squared minus 1 is equal to 0. Now we have the difference of two squares. Remember, you're allowed to do that as long as you do it to everything. Whatever you do to one thing, you have to do to everything. Now, this is the difference of two squares. Yes, you could do the square root with it, but I'm just trying to show the patterns of the difference of two squares. What times itself will give me 225x squared? 15x plus minus, what number goes here and here? 1, because 1 times 1 equals 1. Now I'm going to keep going. 15x plus 1 equals 0, and 15x minus 1 equals 0. Subtract 1 from both sides, and we get 15x is equal to negative 1. 15, over here we're going to add 1. We'll get 15x is equal to positive 1. Divide by 15, divide by 15, divide by 15, divide by 15. And we get x is equal to negative 1/15. And x is equal to positive 1/15, or plus or minus 1/15. All right, moving on to E. Now this is not a difference of two squares. It's not. Like, you can see that it's not. But one of the things that we could do is we could try to see if this factors. I mean, it's something we should check. If it factors, great. If not, we might end up completing the square. We might end up at the quadratic formula. What do you got? X minus 9, x minus 9 is equal to 0. Now, notice I only do one of these. Why do I only do one of these? It's the same thing. It's just going to be one answer there. When you end up with two of the same things, that's a perfect square trinomial. It's the something times itself. That's the same thing as x minus 9 squared is equal to 0. So I'm only going to end up with one answer there because I have two x minus 9s. Let's go over to this one here. I notice now that the leading coefficient is not a 1. It's not. And I cannot divide them all by the same thing. I would love to divide it by a 2. I would love to divide it by a 3, but no matter what, it doesn't work. Give me a strategy I could use. Yep.
Since the first one is a perfect square, can you just simplify it to
Yes. So here's what he's saying. This is a perfect square trinomial. This is a perfect square, and this is a perfect square. So what is it? So do you know what it simplifies to?
2x plus 3.
Good. Notice that this is what happens for these, a perfect square trinomial. The 2x came from here. The positive 3 came from there. So we get 2x plus 3, 2x plus 3. So we're going to set those equal to 0. But of course, I'm only doing one of them. They're exactly the same. So I'm only going to do one. 2x is equal to negative 3. Then we get, divide by 2. And we get x is equal to negative 3 halves. Sorry?
Does the 6x just disappear?
The 6x? No, it's just, here, you know how you wanted to do this, 4 times 9?
Yeah.
You would have ended up in the same place.
Okay.
You would have ultimately got it factored down. You would have done grouping. You would have ended up with 2x plus 3, 2x plus 3. But because this is a perfect square trinomial, it allows us to take some shortcuts there. So even if you didn't recognize it, that's okay. The longer way will still work as well. Okay, I think we have like 3 more problems. Maybe 4. Okay, 4 more problems. I don't think they take much more work, but they do take a little bit more work. Give me 1 second here. I just got to straighten my notes out. Oh, I didn't realize we were still recording there. Okay, so what we're going to do is vertex form here, and we're going to try to make everything look in this form. Like, we're going to get it like a quadratic. So instead of having it look like x squared plus 2x plus 1, we're going to have it look like this form right here. The vertex form allows us in a parabola, remember, to see like how it's been changed. Like this shows me how up or down it has been moved. This shows me how left or right it has moved. Remember, that's a number that is in jail, so it's not a number that we're going to trust. But we can change things to look like that. So yesterday we used the solutions to figure out some things. So first thing that we did was we've got x is equal to 2 and x is equal to 7. And what we can do then is bring them back over to the other side like we did yesterday. X minus 2 equals 0 and x minus 7 equals 0. These are the same things we did yesterday. And we would end up at x minus 2 times x minus 7 is equal to 0. From there, I'm going to FOIL this out, and we're going to get x squared for the first term, minus 7x minus 2x, and positive 14 is equal to 0, which becomes x squared minus 9x plus 14 is equal to 0. So we get here. Now, this does not look like the version up there, the vertex form. Yes, sir?
Subtract 14 on both sides?
Okay, so let's say we subtract 14 from both sides. Let's see where that takes us. X squared minus 9x is equal to negative 14.
And isn't that perfect square? Like in the there? No, not yet. No. I was trying to say.
Well, you could complete the square, right? Like, remember what this looks like is this needs to look like something times itself. So let's see where this goes. Let's see what happens here. So how do we complete the square over here? X squared minus 9x equals negative 14. What should I be doing there? Okay, negative 9 over 2 squared. So, which becomes negative 9 squared over 2 squared, which becomes 81 over 4. So we're doing 81 over 4 plus 81 over 4. Now this factors, right? It becomes x, remember this number that we used before? Minus 9 halves is equal to, now we need to figure out what this is. Negative 14 plus 81 over 4. How am I going to do that? How do I add those together? Okay, good. To be able to add them together, we need these to be the same fraction. So negative 14 over 1, multiply the top and bottom by 4. The bottom becomes 4, and the top becomes 56, if I'm not mistaken. So we get negative 56 fourths. Okay, so what we've got there is negative 56 fourths, and we are going to move it back to, did I do it? No, I'm sorry. We still have to add 81 to that, right? I forgot to add 81 fourths to that. Okay, so what is 81 minus 56? How much? Okay, so we get x minus 9 halves squared is equal to, that's 25 fourths over here. We're going to move it over to 25 fourths. Now the last thing that we need to do is we need to get these on the same side. See how they're on the same side? So all we need to do is get that 25 fourths over to the other side. X minus 9 halves minus 25 fourths equals 0. Now we have it exactly like it looks up top. There is something in parentheses being squared plus something else. Here we go, something in parentheses being squared plus a negative 25 fourths. Yes, sir?
Do we have to write like that? We have to put the x equals.
The f of x, you could put it there as equals 0. You could put it as f of x. Either one, that part is not going to cost you the problem. Let's try another one. We've got x is equal to negative 1 and x is equal to 6. So x plus 1 equals 0 and x minus 6 equals 0. Or x plus 1 times x minus 6 equals 0. Okay, so I'm going to FOIL this out. First times first is x squared. Outer times outer is negative 6x. Inner times inner is positive 1x. And then finally, negative 6. To give me x squared minus 5x minus 6 equals 0. Now remember, if we complete the square, we'll get this to look exactly like we need to. But I'm not ready to complete the square yet. What do I need to do? Add 6. We need to make ourselves that little gap there. And we get x squared minus 5x. There's our little gap. What am I going to do?
Negative 5 over 2.
Okay, I'm just highlighting that blue so everybody knows where I get my number from in a minute. When I square the top, I get 25. When I square the bottom, I get 4. So we get plus 25 fourths plus 25 fourths. Now I already know what this factors into. What does this factor into? X minus 5 over 2 squared is equal to, but now how do I deal with this? 6 plus 25 fourths. Over 1. So 6 over 1, multiply top and bottom by 4, and we get 24 fourths. So we get 24 fourths plus 25 fourths gives me how many? Good. X minus 5 halves squared is equal to 49 fourths. We're almost there. We don't need to square root both sides. We're not trying to solve it. They just want me to write it like this. And they're not on the same side. And I'm one step away from doing that. How do I do that? Subtract 49 fourths. And you can say f of x equals, you could say equals 0, all those would be fine. Okay, so we get x equals 0 and x equals 9. This just becomes x, and this is x minus 9 equals 0, so we're going to multiply times x minus 9. We dealt with that just x yesterday. We ran into that situation and how we came across that. I'm going to distribute, and I get x squared minus 9x equals 0. Let's complete the square. Good. Negative 9 over 2 squared. Okay. So which gives us 81 fourths. So I'm going to add 81 fourths here and add 81 fourths here. That worked out pretty well on the right. That makes it easy for us over there. Over here, what do I get on the left?
Oh, you get
X minus 9 halves over 2 is equal to 81 fourths. This worked out really easy. 0 plus 81 fourths is just 81 fourths. So what do I need to do to finish this up? Just take away the 81 fourths from both sides, and we get x minus 9 halves squared minus 81 fourths is equal to 0. Done. That's good too, yep. All right, last one of having to hear my ugly voice. Here we go. X equals negative 5. X equals negative 8. So we get x plus 5 equals 0 and x plus 8 equals 0. X plus 5 times x plus 8 equals 0. Excuse me, we're going to FOIL that out. First times first, outer times outer, inner times inner, and last times last. X squared plus 13x plus 40 is equal to 0. Where am I going from there? Subtract 40. And I get x squared plus 13x, there's my little blank, minus 40. I hate when they give me an odd number. I really do. Every time they give me this as an odd number, I'm so annoyed. Because every single time, that means I have to go 13 divided by 2 squared. 13 times 2 is 169, and 2 squared is 4. So I'm going to add 169 fourths. Add 169 fourths. What does this factor into here? X plus 13 halves. And again, where do I keep getting that number? It's right there. That's why I keep highlighting it. That's where we're getting the number. Is equal to, well, let's turn negative 40 into fourths. So we get negative 160 fourths plus 169 fourths. That was convenient. X plus 13 halves squared is equal to 9 fourths. How about from there? Just subtract 9 fourths. And that's it, my friends.